Welcome back to WAPC. Today we are going to discuss about the previous year questions on Kcet entrance exam. Okay. Well, our first question is the number of atoms in 4.5 gram of a face-centered cubic crystal, which means an FCC crystal with edge length of 300 pm, which is picometer. Okay, we do know that. Within the given density as 10 gram per centimeter cube. Okay, we have to find out the density. We have given the density, we have to find out the number of atoms in 4.5 gram. Okay, we can know what is the density equation in this situation. We have D is equal to how much? Zm into Na into A cube. Okay, A is the picometer method. Okay, so with this we could say that M is equal to Na into A cube into density divided by Z. Okay, in a face-centered crystal the number of atoms per unit cell is 4. Okay, so the Z value for this equation would be 4, and by stating that we could say that M is equal to Na number of Avogadro number 6.022. We could approximately write it as 6 into 10 raised to minus 10 raised to 23, okay, into density 10 into the edge length A, which is 300 picometer. We could write that as 300 into 10 raised to 8 minus 10, right? 10 raised to minus 10 whole cube, okay? Minus 10 whole cube divided by 4. This is the equation. We have to find out the molar mass of this equation. Well, on giving that, we could say that 10 raised to minus 7. We could cancel out this and this by giving 10 raised to minus 7. 300 into 1800, 8000 into 10 raised to minus 7 by 4. Okay, this is the final equation, and by this M is equal to 40.5. Okay, we have got the molecular mass. Therefore, 40.5 gram of gives 6.022 into 10 raised to 23 atoms. Okay, therefore 4.5 grams gives how much? X is equal to 6.6 into 10 raised to 22 atoms. Okay, did you get the correlation between these two? So far we could say that the correct answer would be 6.6 into 10 raised to 22. Okay, option number D. Okay, we have finally found out the number of atoms. Okay, let's move on to the next one. Which of the following set of polymers are used as a fiber? Is it Teflon, starch, terling, or Orlon? We do know that Teflons are used is not used as a fiber, as utensils include Teflons and starch does not include as a fiber. The only two examples are terling and Orlon. These two polymers are used as fibers. So option C, third and fourth. Okay, we have found that terling and Orlon are both fiber materials. Our next question is, which one of the following pairs will show a positive deviation from Rolle's law? Okay, this is the question that we have here. Okay, which of the following solutions? Which solution does show a negative deviation? You have studied during the solutions part that a solution which has the components A, B, in which the solvent-solute interactions are stronger than the solvent-solvent interaction and the solute-solute interaction. Okay, this is the negative deviation definition. Okay, so for positive deviation we could say that the solute-solute interaction or the solvent-solvent interaction is greater than that of solvent-solute interaction. Okay, this is the this is what positive deviation shows in Rolle's law. So we have to find out which one of the following pairs will show a positive deviation. Okay, a positive deviation. So we can say that water and nitric acid combination has a negative deviation due to the strong interaction between water and nitric acid. So water and nitric acid we could exclude. Okay, acetone and chloroform. This is also has a strong interaction between chloroform and acetone. So due to the interaction, so we could exclude acetone and chloroform. We could exclude also water and HCl because both the nitric acid and HCl have a stronger bond with them because of the strong interaction between water and nitric acid. So the correct option would be benzene and methanol. Okay, this shows the positive deviation of Rolle's law. So option B is the correct answer for this question. Okay, our next question is, in a given sequence of reaction, identify P. Okay, the given sequence of reaction wherein P, Q and S. Okay, this is our question where an ethene, okay, a double bond is treated with the P, compound P, along where it is then treated with the Q, which gives a bromo alkane. Okay, what might be the answer for this actually? Here we have bromine. Okay, first one is an addition reaction, right? HBr or a bromine reaction. Okay, where 2 bromine is added to the alkene group. Okay, so far CH2 double bond CH2 in treatment with the P. Okay, P is bromine, Br2. Okay, we do know that P is bromine. This is then treated with the Q to form an CH2 double bond. Okay, that is a reduction reaction. So we might use alcoholic KOH. Okay, alcoholic KOH. We use alcoholic KOH to reduce that to CH2CHBr. Removal of bromine. Okay, and we could use alcoholic KOH. Okay. CH2 double bond CHBr, okay, which gives alcoholic, reduces to this one. Okay, alcoholic KOH. Then this is then treated with bromine. Alkyl bromide is then treated with something called R to give a triple bond. What do you think might be the reason for forming a triple bond here? Okay, where an R is treated. So we can use alcoholic KOH and reduce to a alkene group. It is then treated with NaNH2. Okay, NaNH2, right? To give an alkyne. Okay, to give an alkyne which is CH triple bond CH. Okay, CH triple bond CH, which upon treating with a red hot iron tube, what is this reaction called actually? Iron Fe, reduction using Fe. Okay, this is then forms an benzene. Okay, 3 CH triple bond CH. Okay, for this the correct option would be option D. Okay, option D, where in the last reaction ethane is passed out through a red hot tube containing iron to form benzene. Okay, so the correct option would be option D. Our next question is, the third ionization enthalpy is highest in which of the following? Alkali metals, alkali earth metals, or chalcogens or pnictogens. So this third ionization enthalpy. What do you mean by ionization enthalpy? The energy required to remove the outermost shell of an outermost electron from the shell of an atom. This is what ionization enthalpy. We have to find out the third ionization enthalpy. So far we do know that the third ionization enthalpy. Okay, the third ionization enthalpy. How can we consider this third ionization enthalpy? Any idea? Well, the removal of first two electrons in alkaline earth metals. Okay, these alkaline earth metals will make them in a inert state. Okay, inert state, which gives them an inert state, so that the third ionization enthalpy. I'm sorry. The second ionization enthalpy in alkali earth metals are make the alkali earth metals as inert state. So far in the third ionization enthalpy, the removal of electron would needed a much higher energy. So that the third ionization enthalpy for alkali earth metals are higher. Okay, earth metals are higher. 33, option D. We will move on to our next question. Okay, identify the incorrect statement. Okay, values of colligative properties. These are the questions right here. Values of colligative properties of colloidal solution are of small order compared to values of true solution. Tyndall effect is observed only when diameter of the dispersed particles is not much smaller than the wavelength of the incident light. Color of colloidal solution depends on the wavelength of light scattered by the dispersed particles. Okay, Brownian movement is due to the balanced bombardment of molecules of dispersion medium on colloidal particles. Okay, what do you think the incorrect statement would be? Okay, well, Tyndall effect is observed only when diameter of the dispersed particles is not much smaller than the wavelength of incident light. That is true actually. Yes, Tyndall effect cannot be observed in such cases. Values of colligative properties of colloidal solutions are of small order compared to the values of true solution. That is also a true statement. Color of colloidal solution depends upon the wavelength of light scattered by the dispersed particles. It's true actually. Brownian movement is due to the balanced bombardment of molecules of dispersion medium on colloidal particles. Actually, Brownian movement is due to the unbalanced bombardment of molecules. Okay, unbalanced bombardment of molecules of dispersion medium on colloidal particles. So option D is wrong, and the correct statement for this is option D. Option D is the correct answer. Our next question is, yes, the incorrect statement about Hall-Héroult process. Okay, what do you mean by the Hall-Héroult process? Actually, it is an industrial method for the smelting of aluminum. It involves electrolytic reduction of alumina. Okay, aluminum oxide Al2O3 when reduced to form aluminum. Okay, it is first dissolved in a molten crystalline. Okay, molten crystalline state with sodium fluoride salt. Okay, this is actually the Hall-Héroult process. We use carbon electrodes in Hall-Héroult process. Okay. So here we have incorrect statement. Okay, the carbon anode is oxidized to carbon monoxide and carbon dioxide. Na3AlF6 helps to decrease. This is the molten state. Okay, molten state Na3AlF6 helps to decrease the melting point of the electrolyte. Okay, melting point of the electrolyte. CaF2 helps to increase the conductivity of the electrolyte. Okay. Oxidation state of oxygen changes in the overall cell reaction. Okay, that's where we must be careful, because oxidation state of the oxygen does not change in the overall cell reaction, it remains the same. So far D is the incorrect statement about Hall-Héroult process. Okay. Our next question is, the transition element present with lanthanoid metal in mixed metal is, okay, mixed metal. What do you mean by a mixed metal? It is actually a 95% lanthanoid and 5% iron combination metal. Okay, mixed metal, misc or mist. Sometimes they use misc or mist. Okay, here it is a 95% lanthanoid. Okay, lanthanoid metals and 5% iron. Okay, so the 5% metal found in misc metal is option B, iron. Okay, we will move on to our next question. Identify the wrong relation for the real gases. Okay, real gases. a real gas. 50 option. Z is equal to V ideal by V real. Pressure of ideal solution is equal to pressure of real gases plus n square by V square, where A are constants. V real is equal to volume of a real gas is equal to volume of an ideal gas minus NB. Okay. Well, P plus A by V square by V minus B is equal to RT. These are the options write down given here. Identify the wrong relation. Yes. Okay. So, what is a wrong relation out here? I think both of these PV equal to nRT derivatives like these are all correct. Yes. V real, V minus V and B, P ideal is also P plus A n square by V square. Okay. The wrong one is the compressibility factor term. Well, compressibility factor Z is given by V real by V ideal. Volume of a real solution by, it is the ratio of volume of real solution by volume of ideal solution. So far, the option A is the wrong one. Okay. Option A is the correct answer for this question. We will move on to our next question. Okay. The correct decreasing order of boiling points of hydrogen halides is, okay, you have to find out the correct decreasing order of hydrogen halides. Okay. So, we have halogen groups are here, hydrogen fluoride, hydrogen chloride and fluorine, chlorine, bromine and iodine. Okay, these are the hydrogen halides which are explained here. Okay, hydrogen halide. You have to find out the decreasing order of their boiling points. That is actually. So, the correct option would be more electronegativity of the atom results in the most strongest bond between hydrogen and fluorine. Okay, so, hydrogen and the halogen atom. So far, the most electronegative atom in the periodic table is fluorine. So the fluor HF is the most strongest one, and to break out that, the boiling point might be higher. It becomes like this: HF, HCl, HBr and HI. Okay. Yes, there's a slight difference in this actually. Well, HF will be the most highest one, and there's a irrelevant trend in this structure as HI, hydrogen iodide, tends to break more easily than HCl and HBr. Okay, sorry, HBr and HI. Okay, fluorine. Yes, this is how electronegativity does not have a steady decrease in down the group. Okay. Okay, our next question is, the synthetically produced radioactive noble gas by the collision of californium with calcium. Okay, californium at 249 and with calcium at 48. Okay, so here we are using oganesson with the atomic number 118 to produce such huge impact. Okay, so far CF, right, californium at 249 and 98 plus calcium 48 and 20 gives what? Oganesson 294, last periodic element. Okay, 118th element plus 3 neutrons. Okay, this is the reaction. The synthetically produced radioactive noble gas is oganesson. Okay. Our next question is, a pair of isoelectronic species having bond order of 1 is, okay, isoelectronic species, which means same number of electrons. Okay, we have to find out the pair of electrons. Okay, well, O2, 2 minus and F2 has both 18 electrons, right? 18 electrons. CO and rather than that, both remaining part of them does not belong into the 18 parts of electrons. Okay, O2, 2 minus and F2. Yes, O2 contains 18 electrons along with 16 plus 2 electrons, and fluorine contain 18 electrons. Okay, therefore both of them are isoelectronic with each other. Okay, 14 and nitrogen molecule and carbon monoxide does not have equal number of electrons. Okay, so therefore option C is the correct answer for this question. So our next question is, A metalloid is, what are metalloids? Okay, have you ever heard about metalloid? We have studied that in the transition elements. Actually, a metalloid is nothing but metals or non-metals having intermediate properties. Okay, intermediate properties acting as a semiconductors include something like boron, silicon, germanium, arsenic. These are all metalloids. Okay. So far we have to find out what are a metalloid is nothing but a serbium and selenium. Both serbium and selenium are a metalloid. Okay, so the correct option would be B or either C. Okay, we have to write either these two. Our next question is the energy associated with the first orbit of He plus is, okay, helium ion, right? Helium ion. Well, to find out the energy, we have the formula En is equal to minus 2.18 into 10 raised to minus 18, okay, into Z square by N square, okay. Well, Z is equal to 2 and number of electrons is N is equal to 1, okay. And by this we could say that E is equal to 2.18, okay, into 10 raised to minus 18 into 4 by 10, okay. We could say that E is equal to minus 8.72 into 10 raised to minus 18 joule, okay, E. Option number B, right, minus 8.72 into 10 raised to minus 18. Nitrogen dioxide is a colorless or a brown gas. It's actually a brown gas produced. So we could exclude these A and B equations. Is it actually acidic or neutral? Every P block elements are acidic. Okay, every P block element, P block oxides are acidic, and therefore 48th question is brown and acidic. Option number C. Right. And our next one is